Okay, great. Away we go. So this is today's presentation, BOM Weather Basics. And we're going to go through a few topics. We've got cloud types, aviation weather hazards, causes of wind changes, weather in the tropics, for those of you who are in the tropics, and a tour of the BOM website, so where you can find all of the information. So I'll start off with the cloud types. I've got a picture here that shows our main cloud types. So we split them into 3 different groups. We've got the low cloud types down the bottom here. So that's your strata, stratocumulus, and cumulus. And we've got our mid-level types, so altostratus and altocumulus. Nimbostratus is a little bit in between, the low and middle level. And up the top, we've got the cirrostratus, cirrus, and cirrocumulus. So these clouds up the top are all made of ice crystals, so they're not precipitating. You don't get any rainfall from those. But the mid and low level ones, we do get some rain or showers from those. And we've got the big cloud on the right is the cumulonimbus. That is the big thunderstorm cloud, and that extends right from the low levels of the atmosphere all the way up to the top. Okay, so we might watch a bit of a video now.
I don't think we're getting any audio coming through on the video there, Gina.
The audio's not working. The audio is not working. Okay. I wonder how I do that then.
We might just have to skip onto the skip over the videos. I just saw a message in the chat that said someone mentioned the videos and Zoom don't work. So we can send the links to the videos after the presentation.
We might have to skip the okay. We can look at rather than yeah. So they're more it's kind of like a flat, darker clouds. You're more likely to see that actually in the southern parts of Australia on a gloomy winter's day, perhaps, and you might see light rain or drizzle from that. The cumulus cloud, this is a puffy cloud, so it looks a bit like a cauliflower or something like that, and you get more intense showers from cumulus, so you get kind of stop-start precipitation from a cumulus cloud. The middle level cloud, altostratus, that's the one that you get more consistent, steady rainfall from, and similar to altocumulus as well. So the cumulus means heap. So the puffy clouds are called cumulus. The stratus means a layer. So they're the layered clouds. And yeah, as I mentioned before, these upper clouds, the ones that have cirro in their name, which means ice crystals, so you don't get any rainfall from them. And then the cumulonimbus is our thunderstorm cloud. So that's just what I've gone through here. So yeah, we tend to get light showers or drizzle from those stratus and stratocumulus clouds. The cumulus is the fairly intense rainfall, so showers. Middle level clouds tend to give us those rain systems, and the high-level clouds are made of ice crystals. So the cumulonimbus cloud, that's our thunderstorm cloud. It produces heavy rainfall, thunder, and lightning. And here are some pictures of those clouds. So stratocumulus cloud, fairly dark, low cloud, a little bit lumpy as well. So you might have a dreary, drizzly day. Here we have the altocumulus cloud down the bottom, so quite a nice looking cloud. That's basically a cumulus cloud that's growing and possibly could become a thunderstorm cloud. And the last one here is an example of a cumulonimbus cloud. So the thunderstorm cloud, it goes up through the atmosphere, and when it reaches the top of the part of the atmosphere, it kind of hits a lid and it spreads out, and it produces this fill of ice crystals there. Okay, so now I'm going to go through some of the aviation weather hazards that get encountered. So I'm going to talk a little bit about fog, icing, turbulence, wind shear, and thunderstorms. And these probably make up the main aviation weather hazards. So fog is defined as a concentrated suspension of very small water droplets causing horizontal visibility to be less than 1,000 meters. So that's how we define fog in the aviation land, and it is a major hazard in Australia. So it's basically a cloud that is on the ground, and it forms on the surface when the surface gets very cold. Typically forms overnight. After the sun goes down, the surface gets very cold and the air is cooled to the point of condensation, liquid condensation, and you get the droplets suspended in the air above the ground. You normally see them in Australia, we typically see radiation fogs. So often there's a high pressure system in the area and you've had a lovely sunny clear day, and overnight you'll have a clear night, and that means that the heat can escape the ground really quickly and cool the ground sufficiently for that air to form fog. Overhead, they tend to act like a bit of a blanket, keeping the heat in, so you're less likely to see fog in those scenarios. Particularly in the tropical areas, you just see shallow fogs, and so they don't significantly affect aviation operations there. But in the southern parts of Australia, they can be quite a problem through winter. And in some places, fog can last through the morning, right through to the middle of the day or even the afternoon, particularly places like Canberra, very fog prone. And the reason it's an issue for the aviation industry is because they can't see when they're taking off or landing or navigating. They can't see the ground if there's a layer of fog there, so it makes it tricky to know where the runway is to land. Okay, icing. So icing is basically when liquid water that's below freezing in the atmosphere freezes on the outside of an aircraft, and so it can accumulate. There's quite a dramatic picture on the left there of some icing on an aircraft, and it is a significant aviation hazard because it can reduce drag on the surface of the aircraft and decrease lift, and it can destroy the smooth airflow over the aircraft. It can also reduce visibility. So icing can happen whenever a aircraft goes through a cloud that is in sub-freezing temperatures, but it's of varying degrees, and so we put out forecasts and let people know when icing is going to be an issue.
Gina, I'm just going to interrupt there. Sorry. I think we've got a bit of problem with some audio. There's some comments coming in about the audio there. We're breaking out a little bit. Are you connected through your phone?
So,
for your audio?
No, I've just got the headphones in, so can you hear me now?
Sorry.
Or is it breaking up a lot?
It's breaking up a lot. Suggests maybe it's your headset.
Can you hear me okay? Does this audio sound okay?
Yeah, Harry, you're okay. Yeah.
No, you're breaking up a bit.
um, yeah, if people can hear me okay, maybe I can take over from Gina if it
Yeah, I can hear you
sounds
fine.
better.
Harry. What about everyone else? Harry's good? Might be an internet connection, Gina.
Go for it, Harry.
Sorry.
Thanks. I'll let you keep sharing the screen then. And can you hear me okay, Gina, or is it a bit choppy at your end as well? Okay, well we'll get on with it. So yeah, as Gina was saying, so icing basically caused by ice droplets crystallizing onto the airframe of aircraft. So you can see in this diagram, it's kind of dependent on temperature. So down the bottom, you've got no icing present because there's basically only water droplets, and that's above 0 degrees. So it's not cold enough for the water droplets to hit the airframe and freeze. But then as soon as you go below 0 degrees, um, you've got a mix of water droplets as well as ice crystals. So those water droplets can be what we call super cooled water droplets. So they're actually below 0 degrees. Um, and once they hit the airframe of an aircraft, they can then freeze on impact. And that kind of high risk range of icing is between 0 and minus 20 degrees when you've got those water droplets that are still present. And then once you go even cooler than minus 20 degrees, most of it's actually ice crystals. So then that means that if the ice crystals hit your aircraft, they'll actually then start kind of bouncing off and they won't freeze onto the airframe. Next slide, please, Gina. So turbulence basically it occurs when the airflow becomes chaotic or random rather than smooth and laminar. So you can see in this diagram, we've got these what we call streamlines coming across the top, and that's what we call laminar flow. So it's smooth flow. But then we've got this topography here, which is interrupting that smooth flow, and it's causing that that mixing, so that turbulence. And then you can see that down the bottom there, we've got these little, what we call eddies, which are kind of circulations in the air movement. So turbulence can be caused by a number of things. One of the examples here is topography. It can be caused by things like different wind speeds at heights, which we'll go through in a moment, which we call wind shear. And it can be caused by things like fronts and lows, tropical cyclones, that kind of thing. So turbulence, I guess, it's defined as it will disturb the aircraft's altitude about its major axis, but it does not significantly alter its path. So you've got the same path, but your aircraft is kind of being shaken around that same path. And this is kind of an important point to note when we get to wind shear, how it compares to that. So there's different turbulent intensities. You've probably all been in an aircraft and you get a few little bumps around and it's fine. And then you start getting into that kind of moderate and severe turbulent ranges where you actually feel the whole aircraft move. They might stop the food service at that time because things might actually be getting thrown around the aircraft and that sort of thing. And then when you're getting into the severe and extreme ranges of turbulence, that's when things are getting tossed around. That's when you need to have your seatbelt on. Otherwise, you can get caused, you can have a lot of injuries caused by people getting thrown around the cabin. And the aircraft may actually be kind of momentarily out of control from that turbulence getting thrown around. It's also important to note with turbulence, it is slightly dependent on the aircraft size. So something that will throw around, a tiny little Cessna, something like a A380 might just fly straight through it with a tiny little bump. So as I mentioned before, wind shear is I guess a type of turbulence, but we define it as so its own phenomena because it has slightly different impacts in that it can displace an aircraft abruptly from its intended path, such that you can lose control of that aircraft off its path. So there's a few types of wind shear. So vertical wind shear is where you've got a change of the horizontal wind direction with height. So you might have wind coming in this example, so 20 knots, kind of pointing, I guess, out of the page, and then you've got another 20 knots above that pointing back into the page. So you've got that difference in wind speeds, and that's so if you're coming up through that zone, you'll be having, you know, maybe a 20 knot headwind, and then all of a sudden you'll be pushed sideways with a 20 knot crosswind. So that's when the wind speeds change with height. So horizontal wind shear is a change in direction, a change in wind speed or direction at the same level. So you could be flying along and you've got a headwind, and then all of a sudden you've got a crosswind. So this happens in things like frontal passages and troughs and that kind of thing. And then we've also got updraft and downdraft wind shear. So that's when the change in vertical wind velocity, I guess, next across adjacent columns of air. And we'll go through this in a little bit when we touch on thunderstorms. That's where it's mostly encountered. Next slide, please, Gina. So yeah, a lot of causes of wind shear. Quite commonly thunderstorms. We'll go through that in a little bit more detail. Frontal systems, sea breezes, frictional shearing, temperature inversions, and then obstacles and rotors and weight vortices such as, I guess, topography, mountain ranges, that kind of thing. Basically, whenever you have a wind change, so, you know, a front or a trough, you can have wind shear around that. And it just depends on how significant that wind change is, as to how strong that effective wind shear will be. So this is the common scenario in the morning period, I guess. So overnight, what happens is we get this what we call a radiation inversion. So this diagonal line coming up here is the temperature profile. So that you can see the temperature at the surface has dropped quite a bit. And so what you have is this area near the surface of really light winds. And we have an inversion above the surface, capping these light winds and providing a barrier between the stronger winds aloft. So then on this boundary, you can have a bit of turbulence there too, because you've got stronger winds aloft and then light winds below. So you've got that kind of turbulent area, and if it's strong enough, that wind shear kind of area as well. And this is common in the morning period because you get a radiation inversion, those cooling of that air below that inversion overnight as the sun isn't present. And then during the day, as the sun warms this lower level, you can then get that inversion breaking down and those stronger winds above the inversion mixing right down to the surface. Next slide, please, Gina. So we'll go on to thunderstorms now. As Gina mentioned before, it's a cumulonimbus cloud in which electrical discharge can be seen as lightning and heard as thunder. So if we have a cloud that's developing, you have a cumulus starting off, it starts growing and growing, and then it gets to a point where it's got enough energy to then create that lightning. So thunderstorm is potentially the most violent and destructive meteorological phenomena confronting general aviation. There are other phenomena like tropical cyclones and that, but I trust that most pilots wouldn't go anywhere near one of those. So down here you can see this map in the bottom left corner is it's a map of the average annual thunder days. So what you can see here is so around, you can see the north of Australia experiences a lot more thunder days than the south of Australia, and basically that's because a thunderstorm needs 3 ingredients to get going. So you need moisture, you need instability, and you need a lifting mechanism. So moisture, the tropics, there's a lot more moisture floating around in the tropics, so that's commonly there. Instability is the ability that a parcel of air at the surface can rise up, so then that creates those clouds bubbling up. And then what we call a trigger is something like a trough or a sea breeze front or something that just kind of lights the fuse and makes that happen. So it just gives it that little nudge to get it going. So that common, the higher end, sorry, those higher numbers in the northern part of Australia are largely due to that extra moisture being present through the atmosphere. Next slide, please, Gina. So it's important to note that all thunderstorms have the potential to be hazardous to anyone in the air, no matter what their size or intensity, because they can have severe wind shear and turbulence in them. Even just your most boring run-of-the-mill thunderstorm can have severe wind shear and turbulence in it. Can also have severe icing and poor visibility and low cloud. The other phenomena are more what we see in more severe thunderstorms. So when you get hail, downbursts, tornadoes, really heavy rainfall, that kind of thing. And we'll go through what that looks like in the warnings in a little bit as well. So the stages of a thunderstorm, as I mentioned before, so you need that air from the surface to rise up, and that rising up is what we call convection. So that air, that warmer air from the surface is going up into that cooler air above it. So that's in the developing stage, and that's where you get the kind of fluffy looking cumulus clouds. And then they develop into what we call towering cumulus, so they gather height. And then once they get to this mature stage, they hit this barrier near the top of the lower atmosphere called the tropopause, and they start spreading out, and that's when they're in the mature phase. And this is you've probably all seen images or seen thunderstorms where you can see that anvil spreading out, and that's when you know that it's a mature thunderstorm. And that's when you get the rain, the precipitation coming out of it. You can get the downdrafts with that precipitation. And then what happens in, I guess, typical run-of-the-mill thunderstorm is that it kind of chokes itself. You can see this, it needs the air going upwards, but it's also got this precipitation pushing downwards. So that precipitation starts to prevent the air coming up into the thunderstorm, and then it starts to dissipate. Some severe thunderstorms or fast-moving thunderstorms avoid this by kind of displacing themselves and continuing on for longer than an hour or so. So one of the big hazards in thunderstorms is what we call microbursts. So that's when we have this precipitation coming out of the thunderstorm, dropping down towards the surface. And as it does, it accelerates this air parcel below the thunderstorm. So in this, on the left here, what we call the initial impact is this area of this blob of precipitation coming down, hitting the surface, and then it starts spreading out. So you can imagine that this area here in the right-hand diagram, you can see those kind of eddies forming on the edge. So that's a very common area of stronger winds and causing turbulence and wind shear. And here's what it looks like in reality. So this is a downburst photographed near Roma in Queensland. So you can see that moisture coming down as this kind of blob. So the thunderstorm is building all this moisture up inside it, and then all of a sudden when it gets too heavy, it's just dropped it. And you can see on the right hand there, it's hit the ground and starts spreading out. And that's characteristic of the microburst, which has those really strong winds and yeah, possible wind shear and turbulence in it. So what this means, if you are going through it, you've got a few areas of very different wind speeds. So you've got in the middle, you can see that really strong downdraft. It's hitting the surface and then spreading out along that surface. And then you've also got these kind of rotors or eddies forming at the edges there. So if you are flying through this or moving through this area, you can experience quite rapid changes in height and airspeed as well. And just go to the next slide too, please, Gina. So there's a few clues you can look for to see microbursts. So dust is a common one if it's a dry microburst. So sometimes they don't have that blob of precipitation to recognize where that downdraft is. So dust, more commonly inland, where there's less vegetation, you can see that dust blowing out, and it has that kind of circular pattern. Virga, which is what we call precipitation that doesn't reach the ground. And this is particularly common if the cloud base is really high and it's hot and dry near the surface. So you can see the precipitation coming down, but then it evaporates as it gets closer to the surface. And precipitation, obviously, as we saw in that image just before. And sometimes, yeah, you'll get reports of wind shear from aircraft operating in the area, or if you might, you might experience some unusual fluctuations in the airspeed around that that area. So another hazard in thunderstorms is what we call a gust front. So when after you've got that downburst, you can see that it keeps spreading out, and that pushes that parcel of air horizontally along the surface. And then that's when you start to get these kind of shelf clouds developing, and then these roll clouds developing, and they can spread out quite far from the storm, like tens to hundreds of kilometers away from the storm, where they keep rolling out because they've got such force behind them from the thunderstorm, and they can actually act as a trigger for new thunderstorms. So if you click again, Gina, this is, you might have seen this in a thunderstorm before. You've got this like lower area of cloud that looks like just like its own little kind of roll of cloud, and that's what that's commonly caused by that gust front that then can travel out from the thunderstorm. Next slide. Yeah, so we found a nice poster from 1982. So it's obviously been an interest in meteorology from then, as it still is now. So this, nothing to worry about, don't bet on it. So you can see down below here, you've got this gust front coming out to the right of the page, and it's causing these fluctuations in the airspeed there. And you've also got that that kind of telltale extra roll cloud there as well. Good little illustration, that one. So we might move on to some weather in the tropics, which is, there's a few, I guess, specific things about the tropics that make it a bit unique. So it's basically, rather than having summer, autumn, winter, spring, it's more apt to describe it as a wet season and a dry season. So dry season is what we're currently in. Prevailing conditions generally good. You look at the satellite image or the news at night, and you see basically the northern half of Australia. It's just clear skies and looks great. There are a few hazards in the atmosphere at this time, so you can still get quite a lot of turbulence with stronger winds pushing up from the south. You can also have a lot of smoke around, given that that is it's the opposite season to when the bushfires occur. So in the northern half of Australia, it occurs, you know, through May till September, given there's no rainfall. So you might have really bad visibility around some areas there. And in the wet season, that's when most of the hazardous aviation weather occurs. So when we generally look at October to April as the wet season. So that's when pretty much all of the thunderstorms occur. A lot of the northern half of Australia gets most of its rainfall at that time, and you get things like monsoons, tropical cyclones, which we'll touch on in a moment. And then between that, there's this transition period when you might experience a little bit of dry season one week, and then the next week you might get a few thunderstorms. So it's just kind of the patterns are readjusting and they're moving further south and north as they sort themselves out. Next slide, please. Thank you. So you've probably all seen tropical cyclones on the news. Hopefully you haven't had to experience one of them. Quite common in Queensland, the Northern Territory and the north of WA. So the tropical cyclone season extends from November through to April. I will move on from tropical cyclones, given that it's unlikely that many of you will be going anywhere near them whilst in the air, I hope. But we can show you where to find more information on the website as to, you know, the movement and track maps and that kind of thing too. Another thing to be aware of is tropical lows. So that's a tropical cyclone that is, its wind speed isn't as high enough to be named a tropical cyclone, but it still can have a lot of low cloud and heavy rainfall around it. So you could get a lot of, you know, days in a row of pretty bad conditions of reduced visibility and that kind of thing. And then the monsoon, which we'll go through in a second, it's basically where you get a lot of rainfall rather than that thunderstorm, like the afternoon thunderstorm type thing. It's more rainfall. So if we go to the next slide. So hazards in the monsoon. So this is basically an area of weather caused by the monsoon trough as it gets pushed further south over the continent. And a lot of warm and moist air comes in from right over Asia and that kind of equatorial maritime area. So you get the hazards in the monsoon. You can get quite strong wind gusts, a lot of low cloud and rainfall, which also contributes to reduced visibility. And you have a lot of what we call embedded thunderstorms. So they're thunderstorms that are hard to detect because they are within a massive cloud. So from the ground or the air, you may not be able to see the thunderstorms. You'll be able to see the lightning, obviously. You might be able to hear it, but it's not as obvious as your kind of run-of-the-mill pulse thunderstorm that has that distinctive cumulonimbus shape in the anvil. Next slide, please. So tropical cyclones, we call it a tropical cyclone if it has mean winds above 34 knots. Obviously, if it's got strong winds in it, there's a lot of wind shear happening in it. So those winds are in a clockwise direction around that cyclone. So if you were to fly through the cyclone, you could experience, you know, 30 or 40 knots pushing you one way, and then you get out the other side and it's instantly pushing you the other way. So obviously a lot of wind shear and turbulence in that. And just like the low cloud, rainfall and reduced visibility there. And you can also get those embedded thunderstorms. You can see on the radar image here, there are these stronger rain bands coming out from the tropical cyclone. And that's when you can get those thunderstorms as well. I guess something to note here too is it's not just a hazard for people flying in it, it's also a hazard for aircraft or anyone on the ground as well. A lot of damage being done to well, not only aircraft, but anything on the ground in its path. And then, so what we have in basically over the northern part of the continent, usually during that kind of transition period is what we call a heat trough. You'll notice if you're in Queensland or NT or WA and you're looking at the weather map, you'll see inland this trough kind of extending all the way down. You know, you can see on the right-hand diagram, it's kind of a little bit inland from the coast. So that's when there's all that heat building up over land, and that has to go somewhere. So it starts rising and creates a low pressure system below it. So you get a heat trough. And this can act as a trigger for those afternoon and overnight thunderstorms. So you can often see big lines of thunderstorms right along the WA or Queensland coast in the afternoon in these periods. So we'll just move on to, I guess, the services the Bureau offers for these severe phenomena. So we'll go through the public weather warnings that are available. So Bureau warns for what we call severe thunderstorms. So I said just before, thunderstorms can have hazards in them no matter if they're severe or not, but we define a severe thunderstorm as having some of these phenomena. So it has to have either large or giant hail, has to have damaging or destructive winds, so that's winds exceeding 90 kilometers an hour, heavy rainfall, which may cause flash flooding, and tornadoes. So most thunderstorms we have don't reach these intensities to warrant a severe thunderstorm warning. Hence why the Bureau doesn't warn for all thunderstorms. So what severe thunderstorm warning looks like is, so this is what we call a regional severe thunderstorm warning. So there's an example from South Australia here, and that yellow area highlights the area of severe thunderstorms, and then the text provides you with more information. So the diagram is a bit small here, but it says for damaging winds and large hailstones in this yellow area. And then if you read the text, it will then tell you exact locations, and it actually gives you information on where the storms are and what time the impacts are supposed to be felt. And then we have the next type of severe thunderstorm warning is what we call is what we produce for the metro areas. So this one's for the Melbourne metro area. So these are cell-based severe thunderstorm warnings. So what we do is, because we have really good radar coverage around the metro areas, and also there's a lot of population there, so the impacts can be quite large, we can issue these cell-based warnings. So you can see in the image, it's got the yellow area, the same as the last one. So this is the area that may experience the thunderstorms, but it's also got that, sorry, if you just go back a slide, thank you. It's also got these red cells on it as well. So that's currently the location where the thunderstorm is currently. And then it also has these what we call range rings. Those arcs in front of the cell is a forecast position of the cell, and it's got the direction of movement. So each of those rings is 10-minute increments of where the storm is expected to move. And if you go to the next slide, please, Gina, thank you. We also produce severe weather warnings. So these are for severe weather that occurs outside of severe thunderstorms. So that might be, you know, in a tropical cyclone or something like that. And these are issued for winds of gale force or more, very heavy rainfall that may lead to flash flooding, abnormally high tides, and unusually large waves. So probably not so much of concern if you're up in the air, and also widespread blizzards if you are in the alpine regions. So what these look like, they look pretty similar to first thunderstorm warning I showed you. So it's got that yellow area of where the phenomena is expected, and it also says on the image and in the title there. So this is for damaging winds over the Tasmanian area. So what we might do now is give you a quick tour of the Bureau website so we can show you. I might share my screen. Oh, it says mine's. Do you want to share the Bureau website, Gina, if you have it available? Let us know if you've got any questions too. Happy to answer questions as we go through. We can show you more information on the website. So I don't have privilege to share my screen at the moment. There we go. So what we can look at firstly is what we call the aviation section of the website. So if you scroll down a little on the website from the main page, so bom.gov.au, you've got that aviation weather services. So that's where all the aviation products are. So you've got graphical area forecasts and that kind of thing. And we've also got, so that the graphical area forecasts give you an overview of their weather expected below 10,000 foot in a specific area. So it'll have showers, thunderstorms, fog, all the hazards associated with aviation. There's also information on how to read these as well on the page. And if you go to the what we call the Knowledge Center, there's a stack of information in here about, so here you can see information about all the products we issue, so how to read them and all that kind of stuff. There's also some pamphlets on specific hazardous phenomena such as thunderstorms, that kind of thing. Then regional hazards, so things to look out for if you're flying in the south or the tropics and that kind of thing. And some more reference material then. So there's a stack of information there to go through if you feel like you need more information on a specific either product or phenomena or something like that. So yeah, lots of information there. I'd highly encourage you to have a poke around there. So we also have the public weather forecasts for towns, districts right across the country. So doesn't look like there's a lot of weather around at the moment, but yeah, you can look at the individual town forecasts, and that gives you a kind of max min temperatures, chance of any precipitation. So it also says things like, you know, frost, fog, thunderstorms, that kind of thing in the description there. We also have something that's extremely well used on our website. It's a radar. I'm sure you're all pretty familiar with it. The radars, there's quite a few radars right around the country. Obviously, it's too hard to cover the entire country, but areas of larger populations and that kind of thing are pretty well covered. You can, as Gina's just done here, you can click on the national radar loop and pick out specific radars that you're interested in from there. There's things like, so in this example, Gina has the observations overlaid on it. So you've got the arrows there indicating winds, temps, and the green, I think, is rainfall since 9 a.m. So yeah, lots of useful tools there. Another useful thing on the website is we've got this pretty cool satellite viewer. Well, we think it's pretty cool because we're meteorologists and we're weather nerds. But it's from a Himawari 8, which is a satellite owned by the Japanese Met Agency. And it's really good, really high resolution for the Australian area. You can do things like you can put lightning overlays, you can play loops so you can see the movement of clouds in your area. You can zoom in and onto a particular location as well. So yeah, lots of things you can do with that sat viewer there. I think we've just lost the website. Another thing we have is what we call Meta-Eye, which we can't seem to see Gina's screen at the moment. So if you're on the front page of the Bureau website, you can click on Meta-Eye, and that gives you forecast information in gridded format. So it's based on a 6 kilometre by 6 kilometre grid for the whole country. And so you can zoom into a specific location, and you can see all kinds of weather forecasts for temps, winds, storms, humidity, all that kind of stuff. And on the front page of the website, we also have that yellow banner across the top, which is where you can get the current warning information for your specific state. And another good resource we have is our YouTube channel. So just go to YouTube and search for Bureau Meteorology. There's some great videos on all kinds of phenomena such as thunderstorms, clouds, tropical cyclones, all that kind of thing. So some really good animations there to explain it probably a lot better than I did. That's basically what we had to present to you. We're happy to answer any questions or queries or anything like that if anyone's got any.
Can I ask a question, Wade?
Yeah, go for it.
Thanks, guys. That was a great presentation. Some of that I knew, but probably like a lot of people watching, there's lots of really good stuff there that just reminds us of some of the basics. So thank you. It was really useful. My question is more to do with wind shear when landing a canopy. Just so you know, we open our canopies somewhere between 3,000 and 5,000 feet, depending what we're doing. If we get a bit of turbulence or a bit of wind shear on the way down, it doesn't cause us too much grief most of the time. If the canopy, which is a non-rigid wing, collapses slightly, it regains air and it's all okay. Where it becomes crucial for us, as you would guess, is that if we get any type of downdraft or wind shear as we approach the ground, it can then give us a pretty hard landing and can and often does end in some injury, broken legs or back or whatever. So any comments or help you might give us on identifying this wind shear, like let's say under 50 feet or under 100 feet?
Yeah. So common, I guess, areas of wind shear where that kind of thing could happen is, like I said, around thunderstorms, obviously, but hopefully you're not really going near them anyway. Again, around troughs and frontal features, that's quite common areas of wind shear. And also, we can also, if you go to the aviation weather, sorry, I can't share my screen, but if you go to the Aviation Weather Services page, we have aviation observations, and in that we have what we call aerological diagrams. So these are for they're not all over the country. So these are the balloons that we send up and gather information on the atmosphere, and they have the winds throughout the atmosphere. I'm not sure if you're familiar with them or not, but that can give you a good indication of lower level wind shear that you may experience. Obviously, those diagrams are from a balloon flight for one point in time as well as space. So if you send a balloon up and then a front comes through, things will change. But if you can kind of look at the weather forecast and the weather maps and say, okay, look, the conditions probably aren't changing throughout the day much, the aerological diagram can give you a good idea of where those wind changes might occur above the surface. The common, I guess, that kind of nocturnal inversion that I described, where you've got the light winds below and then the stronger winds aloft, when that surface heating kicks in and that kind of starts mixing, is also a common time where you get that maybe not so much wind shear, but just turbulent mixing in the lower layers, which can also, I guess, cause a lot of hazards. And that's a lot harder to identify visually, I guess. Things to look out for is if it was windy the previous day, it could possibly happen again that day. So looking at recent observations and getting trends in the recent observations can also help there. Did that somewhat answer your question?
Yeah. No, look, that's all helpful stuff. Thank you.
No worries. Thank you.
Can I just go off the back of that question?
Sure.
So if we're standing out in the field and we look up in the sky and we see blue skies, is there any way we can say, oh, look, there's some wind shear there? Is that possible?
Sometimes you can't.
No, that's what I thought.
Yeah. Yeah. Obviously, if there's cloud, you can see, cloud moving really quickly. And if it's light winds at the surface, you know that there's some kind of wind change with height. But if it's blue skies, even if it's early in the morning and it's nice and still at the surface, it still may mean that there's stronger winds just above the surface that are yet to kind of mix down towards the surface. So yeah, I'd encourage you to try and get, as much information as you can on those winds above the surface as well. So the aerological diagrams. There's other third-party websites that provide you with winds above the surface. That's purely from model data, but it can give you an idea of what's happening above the surface. It's just that we can't really, vouch for the accuracy of it, but it can give you another added, I guess, layer in the picture.
A little bit to add to that, Harrison, if you don't mind.
Sure.
Yeah, so like a lot of paragliders will be able to tell you when, if there's perhaps a thermal coming through, where we can experience wind shear, not from a horizontal point of view, but from fast rising air, which you were going over earlier on. So yeah, where the thermal may be going from the ground up towards a cloud, or observing, groups of birds flying, in a circle, we can see that they're climbing in that thermic activity. So a lot of, by bringing our awareness to different areas of the environment, we can actually see where that wind shear might be created. And as we become a lot more aware of our canopy flight, we can sort of look at the grass and the trees and see, if it's still everywhere else, but a tree is moving in one particular area, that'll be an indicator of that's where the thermal is on the ground.
Yeah, exactly. Yeah, really good points there. Darren has just posted in the group chat and mentioned the grid point winds. So these are available on the Aviation Weather Services page under forecasts. They're pretty daunting to read at first, but they also provide you with information of the winds and temperature above the surface at set levels above the surface. Again, there's some information on the website about how to read them. They're pretty daunting to look at, but once you kind of drill down into what area you're looking at, you can get a bit of information from them as well.
Harry, it's Charles here. Firstly, thank you very much to both you and Gina. I think that, as Richard said, the information that you shared today is very valuable, and it's nice to have it in a compact session like this. Obviously, there's a lot more to learn. This is not the full story. I'd like you to just share a little bit of information with the members, just in a short fashion about the course that you run, because the Bureau of Meteorology runs a 2-day course in basic weather information. If you could just give a short overview of how that works, how you run it, etc.
Yeah, no worries. Thanks for the reminder. Like you said, we could talk for days, weeks, or months about the weather, and we do a year-long training course when we employed as meteorologists to get a better picture of it all. But we have what we call Introduction to Meteorology courses. So these are run over 2 days, and they go through all the basics firstly. So you start off with you know, why the weather exists, why things are moving around in the atmosphere, then moving on to how do we measure all this information, how do we write and read weather maps, how do we produce forecasts, and then it also has quite a few sessions on specific phenomena such as thunderstorms, tropical cyclones, more severe weather, marine weather, that kind of thing. So yeah, they're really, really good courses. We run them quite frequently, and at the moment, you know, in this time, we're actually doing them online at the moment. And to get more info, if you, I can post the link. Actually, that's probably easiest. I'll just chuck it in the chat.
I think Gina just has.
Oh, awesome! Thanks, Gina. Yeah, so there's a bit more information there. There's a course brochure that goes through the detail on the subjects that we go through. But yeah, really, really good course. We get a lot of good feedback from participants, and I think people go away with a lot of information on, you know, how to use the weather information that we provide in all kinds of different contexts, from, you know, pilots to firefighters in the agencies to marine users such as sailors and that kind of thing. So.
Right. Okay. Thanks, guys. Anyone got any other questions or comments or anything to add? But you're right. We could talk about this forever. I know a lot of skydivers out there. We all believe we're experts in weather. Well, most of us are in a particular area. Yeah. So if you guys have got anything else to add, we'd like to thank you again for joining us, Gina and Harry.
Thank you.
Yep, great information.
No worries. Yeah, thanks a lot for having us.
Yeah, you're very welcome.